All right, good afternoon, good morning, good evening, depending on whatever time zone you're in as you review this video or you are online. I welcome you. This is Helen Thomas on the CDFM study group. All right, so today we're going to continue and complete review of CDFM Module 2, Competency 2, which is Cost and Economic Analysis. So last week we did the first part, but it was a lot of information. So I waited until today to complete the other half of it. But before I continue, I like to kind of recap to get us back to the point where we are with the, let's see, we're going to be picking up on total systems approach on 2-2-17. But before we begin that, let's talk a little bit about how we got here. Remember, even though this is a study guide with multiple pages, the process is one big process. There are all these processes that are continuously evolving, continuously being completed. And so you cannot treat the pages when you're studying as if you're just studying on what's on that page right there, because then you're going to lose sight when you get to the exam and they start asking you questions from here, there, and everywhere, because the exam's not going to tell you where the question is coming from. Then it's difficult for most people to refocus and try to figure out where you are, because you've been looking at it as individual pieces. It's a big process, and you're trying to understand where things happen in the process, who's doing it, when are they doing it, etc., etc. So everything begins with that National Security Council. In the beginning of Module 2, we talk about the NSC and the National Security Council, which is made up of the President, Vice President, Secretary of Defense, etc. They come up with the state of the country, our threat, our priorities, and they publish it in a national security strategy. The big op order. What do you do when you get an operation order? You take the operation order from your hire, and then you look through it and you determine what are your related tasks in that op order. So the agency, such as Department of Defense, takes the national security strategy, looks at it for the defense related tasks, and then they come up with the national defense strategy. So how do we get to today? You have to understand that once the Department of Defense comes up with its strategy, now we need to put it into action. But before they can do that, the DoD uses 3 decision support systems. JCITS, Joint Capabilities Integration and Development System, Plan, Program, Budget Execution, that's the PPBE system, and the Defense Acquisition System. Those 3 systems overlap. They work simultaneously to meet the National Defense Strategy, and the National Defense Strategy meets the National Security Strategy. So what is happening in JCIT? So once the National Defense Strategy is published, now the Joint Staff, the highest level of your military, you got the chairman in charge of them, chairman of the Joint Chief of Staff, the Joint Staff needs to do an analytical process to determine, do we have any capability gaps? So they use the JCIT system to determine that. They look at doctrine, organization, training, etc., etc. That's my word for today, etc. So bear with me. All right, so they use JCITS to do that. They look at .mlpf, that's the acronym, and I think it was covered on page 226, that first paragraph. All of that's written in there. And so if it's anything other than material solution that's going to fix the capability gap, then it triggers the PPBE process. We need more funding for personnel, training, and so forth. If it requires a material solution, which is an equipment, it triggers the third system, which is the Defense Acquisition System. So module 2.2 focuses on the defense acquisition system. So for those just came on, I just wanted to recap to get us back to where we were last week. And so JSID identified that capability gap, and at the end of it, those joint staff published the issue, the capability gap, and their recommendation in an initial capabilities document, the ICD. So the ICD becomes the document, the starting point for them to determine the requirements that are needed, the things that are needed, the funding, the equipment. They have that base document to start off with. We also went over, if it's a material solution that's going to fix the problem, we went over the phases, the milestone, the decision points. Before you move on to any phase, you have to have a decision point. So you have what's called a milestone decision authority. That's the senior decision maker at that level. Material solution analysis phase, then you have milestone A, technology maturation and risk reduction. Milestone B, engineering and manufacturing development phase. Milestone C, production and deployment phase, which also includes full rate of production or decisions, and operations and support from cradle to grave. We also talked about the last session that just because you get from milestone A to technology maturation and risk reduction does not mean an acquisition program is in full effect. The program is initiated at milestone B. So as you're going through the process, you are analyzing the alternatives, you're coming up with the one best solution for the problem. You make a decision to move forward. Technology maturation, risk reduction is exactly what it states. We're looking for ways to reduce the risk. And then it's presented at milestone B, and that milestone decision authority makes a decision to move forward. They have the acquisition program baseline, and it's all published in an acquisition decision memorandum. So where we are today now is, how do we come up with the estimated cost for that material, that weapon system, that equipment? On page 2217 is where we pick up today, talks about the total systems approach. I don't want to know just how to build it. This is going to fix the problem. But again, it has a life cycle. How long is it expected to be in service? And then what do I do with that equipment or that weapon system once that life cycle has come to an end? So think of the cradle to grave approach. Page 18, the life cycle cost can be broken down either by the appropriation category that is used, because as we talked about the phases last week, we talk about using RDT&E for phase 1, sometimes O&M. We talk about RDT&E in procurement. So you have to know what type of appropriation is used in each phase. So appropriation category, WBS, work breakdown structure, or is it for research, investments, operations and support, or is it for disposal of that system? So those are different categories that are used to develop that cost estimate, because you have to know how much the program is going to cost when you go to Congress to ask for funding. On the bottom of page 19, so last session we talked about the acquisition program baseline, which is approved by that milestone decision authority, and it is created by the program manager. So when it comes again to the acquisition side of things, 99.9% of the time, your program manager is the initiator of those documents, creator of those documents. For example, the bottom of page 2219, the card document, it says the DCAPE requires the use of a cost analysis requirements description and provides guidance on the content of the card. DCAPE is talked about in actually all three modules: the Director of Cost Assessment and Program Evaluation. That is the title of the senior person at the DoD level who's in charge of, let's see, Future Year Defense Program. They update they're responsible for the programming phase of P. They provide guidance on the analysis of the alternative, and they also provide guidance on the development of that card. We want to know exactly, so the program manager, again, for ACAT 1 and ACAT 1A, the PM will prepare it. It makes sense because they're the subject matter expert on that program, so they prepare them. So the PM, thus far, we've learned, creates the acquisition program baseline. That's the starting cost price. And also the card, which is the cost analysis requirements description. So it's a little bit more detailed. In that first bullet, there's a couple of timelines that you need to be familiar with. It says the draft card, let me read it, must be received 180 calendar days, and the final card 45 days before the planned overarching integrated product team or equivalent staff. So before they get ready to do that next board or evaluation, you have to have that card document in hand. Any question on what I've already discussed before we move on to life cycle? Okay, I don't hear any questions. All right, so page 20 begins, and I don't think it goes into detail. There's a chart also on 22, but I like diagrams because when you take an exam, it's easier to remember if you study the diagram. You can learn the individual parts, but the diagram will be easier for you to remember where things are in the process. So let's look at the diagram on page 20. Life cycle cost composition. It says your first stage of that development is your developmental phase. What you're going to need to know is what type of cost, which is the developmental cost, and what type of funding is used. So as you can see in that box, if they say, what is the developmental cost for this project? And they have developmental, they have RDT&E, Milcon, procurement, O&M, MILPERS. You will pick everything that says RDT&E for developmental cost. Number 2 is called the flyaway cost. And as you can see, the dotted line around it is procurement of the prime equipment. Number 3 includes the flyaway cost, procurement of the prime equipment, plus procurement of the support equipment, support items. Together, if they say calculate the weapon system costs, you have to know, and it's not going to be told, okay, you add these two together and that makes your weapon system cost. Number 4, procurement cost. That is the flyaway cost, the procurement of the support item, and procurement of the initial spares. All those 3 together make up your procurement cost. And you'll see on page 21 how your knowledge of this diagram will then transfer into a practical exercise that can be asked, question that could be asked of you. Number 5 says program acquisition costs. So you take everything we've talked about 1 through 4, so everything RDT&E, procurement, and now you add Milcon to it. All 3 of those categories of funding makes up your program acquisition costs on page 2220. Number 6 is operations and support. So you're thinking of cradle to disposal. Grave is disposal. And then what type of funding am I using through the process? So program acquisition costs adds the Milcon, then operations and support is your O&M and MILPERS. And then your disposal. which is typically your O&M is used for disposal. So that is the level you're going to need to know. So that's why I said study the diagram on page 20, but as we move over in a little bit to 21, you'll see it in action. There's two formulas at the bottom of page 20. It doesn't look like a formula, but they are formulas, because if you're asked to calculate the average procurement unit cost, you're going to need to know what to do. So it tells you the formula: the amount found by dividing the total procurement funds program to be available for obligation by the number of fully configured end items. When you take an exam, make sure you read the whole question. So you may have an example that says you have one partially configured item and 3 fully configured items. It makes a difference because you can only divide by the fully configured end items. So that's using all your procurements divided by the number of fully configured. Then the program acquisition unit cost. So remember, program acquisition cost was RDT&E, procurement, and Milcon. So if you're getting an average, once you add up all of those, and you're going to divide by the total number of fully configured end items. What am I talking about? Let's go to page 21, those two examples. The first one is an example of the program acquisition unit cost. They give you RDT&E. You have one unit, $5,000. Second one is procurement funding for 199 units at $20,000. Milcon funding for 0 units, $1,000. For a total of 200 units, $26,000. How do you get the unit cost? You simply take the total dollar amount, 26,000, divided by 200 to get 130,000. Also on the exams, there's no calculators, there's no use my phone, so forth. So if you don't remember how to do long division, you might want to practice, because you will literally have to come up with that 130 by doing that long division that not too many people do these days. The second example is the average procurement unit cost. So the word procurement is telling you you're only using the procurement dollars. RDT&E, no units given. Procurement, 199, 20,000. Milcon, no units, no cost, for a total of 199 and 20,000. Likewise, since it's a procurement unit cost, we need the total dollar for the procurement and the number of procurement units, which is 20,000 divided by 199. Now, let me give you a disclaimer. Just like in real life, you're not going to only get the information you need to calculate the answer. In real life, you get buku information and you have to pull out what is relevant. So just because in the study guide, they give you exactly the values that you need to calculate the problem. On an exam, they're going to give you more. They're going to give you O&M. They're going to give you MILPERS. Just like that second example, they're going to give you all of them, and then they're going to say, calculate the average procurement cost. So you need to know how to navigate and come back to that particular point where you know if it says average procurement cost, that means I'm only using procurement dollars. And I think at the end of this section where you have the practical exercise, and we'll look over some of those, is you'll see what I'm talking about. All right, so page 2222, always like charts, is organized. It gives you the explanation of the developmental cost. So think of it from, okay, when I get the idea, it's called a developmental cost. I use RDT&E funding. Flyaway, that's the first procurement of the prime equipment. Weapon system cost. Now I add something on the prime equipment, then that support item is a weapon system cost. So learn it in the order in which they occur as you build. So you know if they say, what is the program acquisition cost? And all they give you is the appropriation, or they give you the RDT&E procurement, Milcon, O&M, MILPERS, and they say, now calculate the program acquisition cost. Well, they're not going to tell you that the program acquisition cost is everything RDT&E procurement and Milcon. So you're going to need to know that for yourself. So any question on the life cycle terms that are used in the acquisition process? Because next we're going to move out. Now we have estimates. We're going to look at different types of estimate. We can use these different categories or buckets to know, what do we go to Congress for? How much RDT&E do we need for this project based on that? Any questions? All right. So page 2-23 in your book talks about different cost estimates, and they go in order. In order says, as the initial cost estimate, where your program manager does, is called a program office estimate. So you're going to need to know, depending on the level you are, that what is that estimate called, the POE. Once you get to the, let's say, Army level, Air Force level, it's called the component cost estimate. So this is if something needs to go up to that level, then they're going to do a cost estimate, component cost estimate, program office estimate, component cost estimate, and finally at the DoD level is the independent cost estimate. And guess who is responsible for that? It is that DCAPE again. So that's another job. So thus far, we've learned that the DCAPE is responsible for the independent cost estimate, the programming phase of P, the analysis of the alternative, the future year defense program, and earlier we talked about guidance on the CARD development, CARD. So that's like what, 5 things. So this person must be real important. All right, so those are 3 different cost estimate: program office estimate, component cost estimate, and independent cost estimate. So you need to know what level they're done. So I'm not going to touch on the WBS and so forth. Y'all can read through that. A popular term that comes up on page 26 when you deal with the acquisition is cost as an independent variable, where yes, if something's cheaper, you might want to go with it cheaper, but you got to consider, what are all these standards, objectives, are they being met? Once all of those qualities are being met, then cost becomes that independent separator of which option we go with. So the idea behind cost as an independent variable is that we can reduce costs early on in the project. So last session, we talked about when the acquisition process, what we're trying to do is to reduce, and I think, let me see something, because I like to orient y'all to the book. In that, I don't normally go over the knowledge questions, but on page 223, that first one, it says, what are the 3 programmatic risks that must be successfully managed in an acquisition program? That is cost risk, schedule risk, and performance risk. Cost, schedule, performance risk. Anything acquisition, always remember those 3. That's the reason you have decision points after each phase, is they want to control those risks as they move along in the process. Cost, schedule, and performance. So those are the 3 parameters, and it's listed also on page 26. On page 2-27, cost estimating methods. Now, anytime you take any cost analysis, cost benefit analysis, anything to do with cost in it, you will always see these cost estimating methods. So these are very important. How you will see it again, it's not going to just give you the definition and then you pick engineering, actual cost, analogy. It's going to give you a scenario, and then based off of this scenario, then it'll ask you a question. Your success will come from you knowing what those definitions are. So what am I talking about? Let's go to page 28. Let's talk about the first one, analogy approach. If you read what it says under that paragraph, it's basically saying, I need to know, let's say my example is an aircraft. Analogy approach, I will come up with the estimate of developing that aircraft based off of one similar existing aircraft that I have already in the inventory. One similar existing activity, system, or component is how I come up with the baseline cost for what I'm trying to fill that capability gap. So analogy, strengths, it's quick, inexpensive because I already have one in my inventory. I can just take the price of that one. Its weakness is subjective, imprecise, right? Because again, if I'm developing something, that means the one that I have doesn't have all the capabilities that I needed anyway. That's why I need either more of it or I need to fill that capability gap. So analogy, one similar system, one similar component, I can use the price of that system to come up with my estimate. Approach number 2 is parametric. You can hear the metric behind it. So it sounds like a statistical type of method on page 29. So what's the difference? Parametric says that I have several existing systems that do different things. I can take the cost of this system, whatever this capability gap is. I have, let's say, 3 different systems that have individual pieces of what I need to do for this capability gap. So I take the cost of that attribute, I take the cost of that one, the price for that one, and then I add those 3 together. Parametric approach says that's how I come up with the estimate for that activity. So sometimes parametric is also called statistical method or the top-down method. If they take the time to bold that item, that means it's probably important. So the difference between analogy and approach, analogy have one similar system or attribute, and parametric says I have several systems that have individual different parts of what I need. So I take the price of those individual parts, add it together to come up with my estimate. Engineering on page 30. It's that bottom-up approach because engineering says that I have no existing system. So I have to start from scratch. So it's bottom up because I'm starting from scratch to develop the item. So I need to know how much each individual step costs. So if you'll notice, the engineering one is the most expensive. So when you're studying, these are the kind of things that you're looking for. Engineering is very expensive, time consuming, because you got to start from scratch. So if you had to think of the cheapest or the quickest method, I would say analogy or even parametric, because you already have something out there that you can take the price of those things to come up with an estimate. Engineering is very accurate, but it's very expensive and time consuming. And then actual cost approach. This approach usually takes the actual cost because we may have this aircraft already in inventory, but we don't have enough. So we need more developed. We need more built. And so I can take the actual cost, which is probably easy also, because if it already has all the capabilities that I need, you could say that the strength, little subjectivity, and it is very accurate because that one has all the capabilities that I already need. All right, so those are the different approaches. Now, when you go to page 2232, they're talking about different techniques that you can use. Using expert opinion, you can use the Delphi technique, meaning, okay, you don't have time to sit down and analyze these existing costs. Somebody, your decision maker wants an answer right now. So what the Delphi technique is saying, if you have several subject matter experts, which is for this case, it'll be your program managers, and they have their opinion of what something will cost, you will take all of their opinions, you'll look for similarities, and you kind of go with, if they all have the same idea, then you might go with their response. So the Delphi technique is a method of narrowing a range of expert opinion to achieve consensus. Consensus, they're all saying the same thing. Querying the expert opinions from a group, seeking information and supporting a rationale, summarizing their results. So that's pretty much all I've stated. So when I restate it to you, I'm not going to go exactly as in the book. I'm going to put it where I can understand, where it's easy for somebody who doesn't work in acquisition to understand. So those are the cost estimating approaches: analogy, parametric, engineering, actual cost. And in that, you can utilize expert opinion by applying the Delphi technique. Always recap what you have learned for that section, because just because you move to a different section doesn't mean you forget that piece. So you want to always recap. Any question of me thus far on anything I've covered? Because we kind of jump from different sections to sections. So I want to be able to pause in case anybody have any particular questions that they need me to answer. All right, on page 233 begins the fun. These will be calculations you may have to do on the exam if you see it again. So you'll have several different methods. So the learning curve theory, as you're developing that item, learning curve pretty much says the more you create or develop an item, your workload should improve. The longer you're doing a job, then your workload should double. That's the idea behind it. As quantity of a product produced doubles, the man hours should decrease. It should take me less time to develop something that I've been doing for 10 years, for instance. So learning curve theory. What would you have to do if you see it again? Let's go to page 2234. Around the middle, you have type 1 and type 2. That means some of the information will be given to you, and you may have to calculate what is the learning curve percentage. How much man hours will it take to double your workload? So let's look at type 1. Type 1 says, given the time required to produce a specific production unit and the learning curve rate, you must determine the labor time to produce the double production. So in that first bullet, you're given unit 1 is going to take you 300 hours, and the learning curve percentage is 90%. Determine the hours required to produce units 2 and 4. So think double. So unit 1, 300 hours at 90% equals 270 hours to get to unit 2. So unit 2 is 270 times the 90%. Your learning curve percentage remains the same throughout that process. Equals 243. So it takes 243 hours to get to unit 4. So if you continue this process and it says, how many hours does it take to get to unit 8? Because it's 243 and so forth. Double 4, and then it's 8. So unit 4, then unit 8. Who wants to do that? I'll pause for a little bit. I have to pull up my calculator now because I didn't do that one. So what it's saying is you have to take that 243 times that 90%, and that will be how much it takes to get to unit 8. Anybody wants to take a stab at it? Unit 8.
Is it 218.7?
Yes, ma'am, that's correct. To 18.7 to unit 8. And you can continue the process. So that means when you see it again, they might give you unit 1, 300 hours, 90%, and they say, calculate and tell me how much it takes to get to unit 16. And then you have to kind of walk through that process yourself. So I just want to introduce you. That's one method. Let's say they don't give you the learning curve, and type 2 says, you given the time required to produce, let me just read, given the production time, so we give you the hours, we give you the units, and they're asking you for the learning curve. With no calculator, with no phone, you got to come up with the percentage. All right. So it's saying, so how you would do it is, so unit 4 is take that 237.5 divided by 250. If you're good with longhand, me, not so good. So what do I do if I'm taking an exam? They're going to have 4 possible answers, right? So what I do is, okay, let me take the percentage for, let's say they have 80, let's say they have 75%, 85, 95, and 65. What I do is I'll take 65% of the 250 and I'll say, do I get 237.5? Probably not, because that's not the right answer. I'll take the second response on the exam, 75%. So I take 75% of 250. I should get 237.5. Do I get that? The answer is no. I do the same thing with 0.85 and 0.95. So I was like, voila, once I do 0.95, let me double check myself while I'm talking to y'all. 0.95 times 250, guess what? I get 237.5. Let me continue. I should be able to take 237.5 times 0.95, and I should get 225.6. Voila, I do. So now I know the learning curve for this particular problem is 95%. What are your questions? Because I know I kind of went off. The learning curve, again, as I stated in the first example, will be the same for that whole process when you're going from unit 2, 4, 8, 16, 32. So if they give you the hours, know that if you multiply that first hours by that percentage, it should give you the next hours. Any question? And let me check the chat in case anybody typing. All right, good. So for that example, type 2, it's 95% for each one. That will give you the hours to 16, hours to 32. So that's your learning curve theory. Less hours producing and doubling your workload. Now on page 35 and 36, they just give you different families, types of contract, fixed price, cost reimbursable contracts. I'm not going to go through none of that because I know I need to get over to page 37. So this is switching again to a different type of, don't forget, cost and economic analysis. So everything going to be about calculating something. This is the reason why, yes, module 2 tends to be a little bit more difficult for individuals because you got to be able to navigate and switch and rotate when they come to these different topics. Earned value management, it states, is an integrated tool that relates technical performance What it's doing is simply a tool that is used between the contractor and the contracting representative, COR. It's a tool for them to check cost, schedule, performance, cost, schedule, performance. We still within, you gave me an estimate to do this job. You said that by halfway, it's supposed to cost me this amount. Is it costing me the same that you said? Is it more? Is it less? What is the value of the work that you've completed? So those are the kind of things you're looking at. This particular section is extremely important. And if you move on to module 4 after this is over, you will see EVM extensively, and you have to know all the formulas to do it. So let's take it slowly here. All right, so the first term you need to know is performance measurement baseline. All right. Okay, we talked about the baseline before for tracking the contract. That is what EVM is. What is our baseline? What did we start to say? You gave me your estimate of how much it's going to cost for you to develop that aircraft. Now let's sit down with the earned value management process tool to determine how are we performing based on that estimate. In the middle of page 37, it talks about the budgeted cost of work schedule. If you notice, also in highlight, PMB is the same thing as budgeted cost of work schedule. So that performance measurement baseline. So if either term is used, know that you're talking about the same thing. So budgeted cost of work schedule may also be considered the planned value. When you have someone come to your house to give an estimate, they tell you how much is going based on what it is that you want done, how much is going to cost you to do it. And then once you do it, once you renovate your house, you expect your house to be valued more than when you first did that job. So a lot of it is based on the schedule. You told me it's going to take you 2 weeks to get the job done. You did it in a week. That's probably good. But is the value of the work still equals to what I want? So for you to be able, I'm going to go through the terms and then I'm going to hit the diagram on 39 where it'll make more sense because it's hard to explain just with the words. All right, so we have budgeted cost of work schedule is the same thing as performance measurement baseline. On page 38, on the cost side, because we talk schedule, now we're talking about cost. They mention, hold on. Yeah, they talk about cost variance and schedule variance. It's going to come up after that one. Cost variance is the result of comparing actual cost of work performed, they're giving you the formula, to the budgeted cost of work performed. BCWP can be considered the earned value of work actually performed. What are we talking about? Let's move on to the diagram on page 39. Then we can come back to the direction. All right. So on page 39's diagram for the EVM, you have 3 projects, project A, B, and C. So what we're going to do now is measure their performances, and then we're going to determine which one appears to be the most on target or unfavorable. So from this particular diagram, where it says schedule variance and cost variance, that is typically not given to you. You have to come up with that. And again, we'll look at the practical exercises at the end so you can see how you will work this. So the budgeted cost of work schedule based on what's on the left is BCWP. Okay. Schedule variance is the budgeted cost of work schedule to the budgeted cost of work performed. And the formula is BCWP minus BCWS. That's just schedule variance. Variance, what's the difference? So BCWS, planned work cost. How much did it plan to charge me for project A? $487. Budgeted cost of work performed after the job was done. So I'm looking at two charts. All I'm looking at is 1, 2, 3, and 4, those first 4 columns. So the value of the work once I was done was $487. So I would say on schedule, it's on target. It's on target because it says when you get the job done, I planned to spend $487. The value of the work should be $487, so I'm on target. Project B, I planned to pay $250, but the value of the work, which is BCWP, is $217. That don't make sense because, again, if you're doing the work, I expect the value to increase or stay the same, not lower. So the schedule variance is unfavorable. Option C, planned work, BCWS, based on the schedule, the planned work is $719. Once you finish the schedule work, then the value of the work was $847. Voila, this is favorable. Now let's go to the second half of the formula, which is the cost variance. Cost variance is the last 3 columns. The value of the work and the actual cost. So the value of the work is $487. The actual cost is $487. So cost variance is exactly what I plan to pay, is on target. The value of the work is $217, and what I actually paid was $122. So I'm on favorable. That's good. The value of the work, $847. The actual cost of what I paid was $875, which I paid more than what is valued, then that's unfavorable. So you got to think of it in the sense of schedule, getting the work done, and the value of the work once it's done on that schedule, when that schedule is up. And then cost variance is the value of the work that's done compared to the actual cost I had to pay that contractor. So something similar to this diagram will be what you have to do when it comes to EVM. And no, the formulas will not be given to you. But what you'll see in the formulas, you got the budgeted cost of work scheduled and the budgeted cost of work performed. If you look at the formulas, you will see for the cost variance, the BCWP minus actual cost of work performed, this cost, the schedule variance is also BCWP minus budgeted cost of work schedule. What are your questions? So this particular area, I will advise you, understand it, get back in it, write the formulas down, because you'll see both variances start off with BCWP. And then we say that the BCWP is the same thing as cost. Hold on, I'm looking in the book. Earned value. Based on page 38, cost variance can be considered, BCWP can be considered earned value. So if they say, what is the earned value? Know that they're telling you what is the BCWP. They're asking for that. All right, what are your questions? And I can't make it any simpler, unfortunately, than what it is. So you'll get it if you take more time and get back with it. All right. So the next few ones are different ways in which the Gantt chart is just different ways of doing that earned value, looking at the progress of that particular project is different ways to measure the starting point, where you started, the timeline, where you are in the process, or the schedule, how long that project's been going on, and so forth. what you need to know here is, when do you use the Gantt chart? This type of chart is useful for planning and scheduling projects, page 41, or the PERT chart, and so forth. So all of that wraps up the cost analysis side of this section. And then you go to economic analysis, which begins on page 42. A lot of that is information. Page 44 gives you the process of what you go through, establishing your objectives, how to identify a benefit. So just kind of read through these, understand the difference on page 46 of cost savings, cost avoidance. You have some benefits that are quantifiable. That means you can tag a dollar sign towards it. If I save something, save money, cost savings, or I avoid having to pay something, cost avoidance, there's a dollar sign associated with it. So on page 47, they're not going to say, is this a quantifiable benefit, or is this a non-quantifiable benefit? They might say, all right, the number of meals, what is increase? This particular benefit increases the number of commodities or items produced for each alternative. So they give you some examples on page 47 of what constitutes a quantifiable benefit. So if these are listed, then you know these are quantifiable. I can actually come up with a dollar savings. On the other hand, on page 48, you have benefits of making that purchase, making that particular aircraft. There's some benefits to it. The benefits can be non-quantifiable. Adaptability, it's easy to adapt no matter whatever service you work in. The technology is easy to adapt. Availability, it's easy to get the parts. Functionality, maintain. Morale. So morale, you can't really put a dollar sign on it, but if it enhances your morale, which when you enhance morale, people tend to work harder or more dedicated, that might be something that's important to that decision maker. And so these are some examples of non-quantifiable benefits. So when you are looking at the total systems approach, you're not only looking at how much the dollar cost of things are, you're also looking at the non-quantifiable benefits of making that decision. So page 49, they give you an additional list of examples of non-quantifiable benefits. Any question on those before we move on to statistics? All right, so your statistics begin on page 50. That's your mean, median, mode, your standard deviation, and so forth and so forth. So because you don't have a calculator on the exams, a lot of this is things that you can look at the formula and kind of know how to navigate to actually come up with the response. So you need to know on page 51 that the mean is taking an average of the values that are given. If they give you numbers 1, 2, 3, 4, 5, 5, they're probably going to mix it up. Know that whenever you do statistics, it's best to put the numbers in order. So if they have the numbers jumbled up, put it in order first if it's a set of numbers, 1 through 10. Because you may be able to clearly see the mode. The mode is the number that repeats the most. Or the median, you may be able to, if you put it in order, you may be able to see where the midpoint is without actually doing any calculations per se. So mean, you add up all the values and divide by the number of values. Median is once you put the numbers in order, which number's in the middle? Is it a clear number 3 is in the middle, or is it 3.5 that's in the middle? And mode is the most frequently repeated number. And then you ask yourself, okay, so what? What does these results tell you? What does the mean tell you? What is the median, the mode? And you kind of think of it as when you take an exam and they say, right, well, most of the people got 90% on this exam. That's your mode, right? So it kind of tells you, okay, well, most of everybody got it and so forth. Or the average for this exam was 85%. That means the majority of people is scoring in the middle, in that median. So those are your measures of central tendency. What is the tendency for the next person to score 85%? Central tendency. 52 is measures of dispersions, where based on if this is the center, how is the data dispersed in that process? What is the range? What is the standard deviation? So the range is if you put the numbers in order, you can clearly see the lowest number and you can clearly see the highest number. Again, because it's an exam where you don't use a calculator, then it should be enough numbers where you could take your scratch paper and write it down for yourself. The larger number minus the smaller number will tell you the range of the numbers in that set. Now, standard deviation is often given. I haven't had anybody who said they had to remember or calculate the 68.27% is one standard deviation. I haven't had anybody in all my years of doing this, but it's listed on the bottom of page 52, and they will show you in those diagrams the dispersion of the data. It'll tell you, actually, I think in the next when we do correlation, it'll show you what does the data mean. Statistic is not just calculating and it give you a number like, okay, so what does it mean? So that's kind of what you're looking at when you look at the diagram. It's page 53, frequency distribution, how you present the data. It can either be a bar graph, which is the top left diagram in the frequency, or test scores. And what are they comparing? Histograms are bar graphs in which the frequencies are represented by the lengths. A frequency polygon is a line graph formed by connecting. So you're going to look at how the two things that you're comparing, do they relate to each other? So frequency. Skewed data. If your diagram looks like the top right, that means the data is skewed, that something is off. It's not a nice bell curve, so something must be off. It's either positively skewed or negatively. I think the depth of what I've seen and what other people usually tell me is if you see the diagram on the top right and they show you the one on the left, you need to know, okay, that's positively skewed, or the one on the right where everything is going to the right, that's negatively skewed. And then we're going to look at what that means. Any question? Or you can infer on page 54, inferential statistics. Inferential statistics. So there's two different ways based on the information given. So let's look at example 1. You are in a supply department and it's January the 1st. You have 100 engines in your inventory. On February the 1st, now you have 75. By what percentage did the inventory change? So reading the question, it did not say, well, take 100 and minus 75. That must be my answer. 25? It didn't say how much was left in your inventory. And when we take exams, we're tend to quick to be like, oh, that must be 25, because yeah. But that's not the question asked. The question says, what's the percent change? And how do you do that? Because it makes a difference of picking 25%, or you will see the example for this is negative 25%. So what it says is take the 75 minus the 100. So 75 of 1 February, the 100 of what it was before, divided by the 100 times 100, because you want the percentage. And so you will see that you come with a negative 25%. And if you're taking an exam and I'm writing the exam, I'm going to have a positive 25% and I'm going to have a negative 25%, because I know that the human tendency is to pick something we recognize right away. It's like negative 25%. That doesn't make sense. But you see, it does when you're talking about percent change. And so for the example one, it says the decreased change in inventory, therefore, was a negative change. So is it a positive change or a negative change? So it's not simply, well, I have less inventory, so it must be the 25%. Example two, now we're in March. So we had 75 in February. March, now we have 100 engines back in the inventory. So if you follow the same pattern, so the 100 that I have in March minus the 75 divided by 75, because you do what's in the paragraph, in the parentheses first, times 100, you're going to see that you end up with, who could tell me how much that is before I give it to you? On page 2254, what is the
33.
percent? How much?
33%.
33%. So what is the percent change? So the percent change is an increase. You already know it's an increase anyway, right? Because it went from 75 to 100. So the increased change in inventory, therefore, was a positive. And you kind of know it's positive because, again, I have more than what I had. But if you're asked for that percent amount, you have to do that calculation. So basically, I went through that to let you know, yes, if they simply ask you, is this change positive or negative? Yeah, you can guess it without calculating. But if they ask you for the actual percentage, you got to be able to calculate the percent change. And I've seen hiring boards where they ask, I'm like, why would you ask them those types of questions? What's the percent change in this process? But this is how you do it. Now, correlation starts on 55, but we're going to go over to page 56 because I like diagrams. Is now you're looking at, let's use the right term, measures of correlation. The top left, 85%, that says they're comparing productivity to examination scores. Individual, depending on how they score. So the higher they score, their productivity also increase. So based on what I see on that top left diagram, I say, okay, those two things have a strong correlation to each other, right? So data in the chart on the left between training scores and productivity, therefore it can be assumed the higher the training score of the individual, the higher the productivity. So those who score higher on the exam, they also produce more. Versus the diagram in the middle, do they have a correlation to each other? If I'm comparing the number of errors my employees make versus how they scored on an exam, well, let's see. The higher errors, well, data in the middle chart indicates there's a negative correlation between training and the errors that are made. Therefore, it can be assumed the higher the training score, the fewer errors that individual will make. This indicates the highest scoring individual will do a better quality work. So if they have a negative correlation, that means the higher they score, the less errors that they will make. So you got to be able to explain the data. And then the third diagram on page 56 is no correlation to each other. That's age and examination scores. So it doesn't matter what a person's age is, it doesn't tell you whether they score higher or less. Excuse me. Coefficient of variation, I don't think we really go over these, but on page 57, a tool that helps us determine the relative dispersion of two or more variables. I haven't had I don't have anything marked next to this, so I'm not going to cover it. Some definitions you need to be familiar with on page 58 as we talk about cost analysis. Constant dollars versus current, and then the definition of sunk cost. Constant dollars is you come up with an estimate, but you do not consider inflation in that price. Current dollars are expressed in the value of the year in which it costs, and it reflects inflation because we know that the dollar will not be worth the same next year as it's worth this year. So we have that time value of money. But before I go into that, felt like I needed to say something. Any question of me of anything we've covered so far? As we're getting ready to switch gears again and navigate. So time value of money, starting on page 59, is the idea that the value of the dollar today will not be worth the same in the future. And so as we're coming up with the life cycle cost of a project, we're going to have to discount the additional years to come up with a value. On page 60, 99% of the time, these values are given to you. You don't have to calculate that, the discount factors. On the bottom of 60, so let's say, assuming a 4% discount, and you have a 5-year project, don't forget, it's not just developing the item, you have to sustain it for an additional 5 years, and then it's disposed. So using the values on the bottom of page 60, we're going to do page 61. I'm going to try to take my time. But based on what it says, if on the exam they says, let's use the mid-year discount, make sure you read on the bottom of 60, it says assume a 4% discount, okay? Year 1 through 5, mid-year discount, year-end discount. If it doesn't say mid-year, that means you're calculating for that whole year. What am I talking about? So year 0 represents the year you make that initial investment. Year 1 through 5 is now I'm sustaining that equipment. So let's go to 61, and I'm going to try to just use that chart to get us there. So if all I'm looking at is this chart, I didn't read nothing else. What this chart is telling me is I have a project, and it's a 5 years investment. I have annual costs or yearly costs. Now I need to figure out what is that yearly cost? What is that yearly benefit? I have to discount it. So let's go to the first column. Column 1 says years since proposed investment. So it's year 1 through 5. Column 2, expected yearly cost. This is how much I expect to pay every year. First year, $10. Second, $20. Third, $30. Fourth, $30. Fifth, $10 for a total of $100. The third year, I expect to get a benefit. Year 1 and 2, 0. Year 3, 35. Year 4, 50. Year 5, 75. Now, what you're calculating is the end of year discount, present value of cost, and the present value of the benefits. I want to know today, if I did that whole project for 5 years, how much is it going to cost me based on today's dollar discounted? So the value based on what's given on bottom 60, so that is the year value, is given. Number 4, column 4. And you calculate column 5 and 6 based on the instruction. So it's simply taking, for the yearly cost, you're taking that $10 times that 0.96515, you get 962. But for the benefits, we didn't have any benefits, so that's 0. All the way down, and then you add up the total present value cost, which is, what is it, $88.64. If I'm using today's dollars, by the time I'm done, it's really only going to be valued at 88. And then the benefit is 135.50. Let me. So they try to explain it on the example on page 61, what I went through. So if you go over it and you have questions, please let me know so that I can explain it. Again, on the exam, don't memorize this chart because I promise you it probably won't be this same chart. But know that the values are normally given to you. However, if it's not on page 60, you see at the top there, it tells you how to calculate the present value for year 1, 2, 3, and 4, and how they came up with those values. So you can calculate it if it's not given. And they say 4% rate. If they said it's 2%, you'll put the 0.02 and you do the calculation there. On page 62, break even is how long will it take me to earn back my money once I make an investment. Based on this example, my investment was $1 million. Savings, based on my decision making, I get a proposed system with an annual operating cost of $50. The proposed system that I'm trying to invest in has an annual operating cost of $300,000, therefore saving $250,000 per year. And so investment is my million, my savings is that 300,000 minus the 50, and $1 million divided by 250,000. That means I will break even in 4 years. I will earn back that $1 million investment in 4 years. What are your questions before I move on to the exercises? Because we still got some time. Now, I typically don't do the exercises, but for module 2, this section, I have to, because it's difficult sometimes for individual to see what we're talking about until you see an exercise on. So let's look at 2263, going back to the life cycle costs, knowing development costs, procurement costs, flyaway, and all of that. If you don't have it already filled out at the bottom, this is probably all you may get. At the top, they'll give you all the different categories. And if you get it, it's not going to be in order. So you're going to have to know, okay, which values do I pull down? And so they might say, what's the developmental cost? So based on the definition of developmental cost, it is 400,000 total RDT&E. Flyaway cost, which is that procurement of that prime equipment, is 600,000. Then you add the weapon system cost, which is that support item, an additional 50 million, which is 650 million. Procurement cost, that's everything that has procurement dollars with it. So you have 3 of them there. That's 700 million. Program acquisition cost, that's everything RDT&E, procurement, and Milcon added up together, which is 1.2 million. Operations and support is MilPers and O&M, which is 1.2 million. Life cycle cost is everything, 2.4. Any question on how to calculate those? Okay. Likewise, page 2264. After being used for developmental test and evaluation, 3 units of weapon systems acquired with RDT&E funds have been successfully modified and are planned to be deployed to operational commands. These 3 items are considered fully configured end items produced for the acquisition program. There are 297 fully configured end items procured with procurement dollars. And I don't know, your book should have the answer already there, or the different choices. Who could tell me how much is your program acquisition unit cost? Program acquisition unit cost. We can work these together. So let's find that page. Because I know some of you came in a little bit after. The PAUC. So you got the program acquisition cost, which is what? Who can tell me what makes up the program acquisition cost? Y'all sleeping on me today? That's everything RDT&E, procurement, and Milcon. So let's see. We have RDT&E, 3 units, 297. How much is it now? So since they don't give you the dollar amount in that second paragraph, second example on page 63, at the bottom, I gave you the program acquisition cost of 1.2 million. All right, so let's do this. So it's 1, 2, divided by 297 fully configured, procured with procurement funds. So if you read the question, you see that program acquisition unit cost is RDT&E, procurement, and Milcon. I'm thinking as I go, make sure I'm saying this correctly. The 2 bullets on page 64, the first one addresses RDT&E. So up there I have 3 items fully configured. Then the second bullet says I have 297 fully configured that I use procurement funds for. So that means I have how many fully configured items to calculate the PAUC? Nobody gonna talk to me? All right. So that means you have to add the 3 to the 297, giving you that 300 fully configured items. And you're going to use the 1.2 million. Likewise, the second one says choose the correct answer to calculate the average procurement unit cost. So procurement says I'm only concerned with the procurement dollars. And so what is my procurement cost is 700 million based on page 63. 700 million and 297 fully configured items. Yeah, items. So this is an example of making sure you read the question. And then on page 65, unit cost in labor. They give you the unit number that double the learning curve. The learning curve is 90%. And then they're asking you for the labor hours for units 8 and 16. So it's just taking 90% of 153.9. Then you should get the value for number 8, which is, I think, what, 138.5. And then you take the 138.5 times 90%, and it'll give you for unit number 16, which is 124.7. The other part of the learning curve on page 66 to come up with the percentage. And again, like I said, is you can either, it's asking you what's the learning curve percentage. My way of doing it is taking the responses on the exam, take the 700 hours, multiply times the percentage and see if I get 595. Or I take the 595, multiply by the responses, do I get 505? So once you do that, you will see that it takes, what is it, 85% is the learning curve for that example. And they're all the same. And then finally on page 67 is the EVM example of what we did earlier. Is you have to come up with the schedule variance based on this diagram and the cost variance. So although it's given to you here, when you see it again, it probably would not be given to you. So you got to know, is it on target, favorable, or unfavorable? So schedule, if the schedule says I'm supposed to finish the job in a week and it's going to cost me let's take the second one, $250. And then once I complete the work in that time, and the value of the work, which is BCWP is value. So let me put value next to it, and it's valued less, then that's what makes it unfavorable based on schedule. If you base it off of cost and it's valued at 216, but it costs me 122, then it is favorable. That's for option B and likewise. So I just wanted to make sure that you see those examples. And I will pause here to see if anybody has any questions. Let me do these calculations. All right, so this concludes CDFM Module 2, Competency 2, Cost and Economic Analysis. I highly recommend that you go over this section again. As you can see, there are multiple topics that switches back and forth in this whole cost analysis. But this focuses on the acquisition system, which is the third DoD support system that you need to review. What are your questions as it pertains to CDFM Module 2, Competency 2, Cost and Economic Analysis? All right. I don't hear any questions. All right, this is Helen Thomas and the CDFM study group. So next week, we're going to continue with strategic planning and organizational performance management. Now, based on the breakdown of the exam, and you can take the 2020 exam runs until the end of September. So I'm going to continue teaching out of this with this format until September. And then we'll switch, since the exam is going to switch. I don't think the textbook switch, is the types of the amount of questions asked from different sections is going to switch. So cost and economic analysis accounts for 14.4% of the current exam, the 2020 exam. Let me put it that way, because they're getting ready to start the 2024 exam. So defense budget process, 33.6. You have fiscal law, 34.9. Strategic planning and organizational performance management, 17.1. In this section is the least questions at 14.4%. All right, that's all I have for today. This is Helen Thomas and the CDFM study group. If you have not already subscribed to our YouTube page, please go ahead and consider clicking that subscribe button, that notification button, so every time I upload new videos, you'll get a notice that the videos have been uploaded. And if you ever have any questions on anything that you hear on the video, maybe I say something incorrectly. I'm a one-man or one-woman show, so it's possible. So just leave a note on there or send me a message so that I can correct it. So I thank you all for stopping by. This is Helen Thomas on the CDFM study group. I'll see you guys again next time. Thank you.